stage is yours.
Thank you. Hello, everyone. I'm very happy to be here. I hope you are happy to be here for the last day of this amazing conference. So before we begin, I have a question for you. Okay, I have a question for you. Okay, is access management a bounded context? So this hotel is called La Folie Douce, or Sweet Madness in English. It's in France, in Chamonix. And it was the venue of our last seminar at my company, AGICAP. And as you can guess, to book such an hotel, you have to plan it in your treasury. You have to plan the cash for it. And you have to make a payment for the reservation. So we have a great tool for that, which is called AGICAP. And in this tool, so you can make a payment, among other things. And imagine that someone from my company goes to the AGICAP payment page and saw this payment to the La Folie Douce Hotel. So they would have guessed the venue of our seminar. And as a good employee, they would tell everyone at the coffee machine, right? So the surprise will be ruined. And office manager will be sad. But in this case, it's not very dangerous, right? But in some cases, it can be very serious for your customers. So access management is a really, really important aspect of our software. It's a very critical element. And even in 2024, it's very painful to build such a system. So I'm Pauline. I work for AGICAP. I live in the French Alps in Grenoble. And I'm not related to the Jamin candy store in Amsterdam, but they should offer discount, right, for people sharing the same name. Just saying. So at the beginning of our product, we had a little SaaS, and we only had like one simple authorization rule, which was a user can access entity only if they are member of this entity. Simple rule, because obviously you don't want your customer from another company or entity to go to see the financial data of another customer, right? So we need to have this authorization rule everywhere. So, for example, we have user Bruce. He has access to entity Wanker because he is a member. Simple rule. So how did we model that? Basically, we've just a joint table between entities and user. I think it's the most common solution for this kind of problem, right? So we did this, we just checked our authorization rule by querying our database, and that's it. But then, of course, our business became more complicated. And actually, we needed internal support, our customer success and support engineers, to be able to help our customers, right? So we needed them to access the entity of our customers. So the first rule was, okay, if the entities, the customers, are in demo mode, meaning they have no subscription, everyone, not everyone, but customer success and internal user and support, whom we call staff, they can access this entity. So simple rule, so Gordon, he can access WainCorp because the entity WainCorp doesn't have a subscription. Okay, so how did we model that? Again, with a very simple rule, we used what we had in our database. We had the subscription, and basically if the subscription ID was null on entities, it meant that there was no subscription for this entity, right? So we were just checking, hey, is the member a user of this entity? Or if there is no subscription and the people is staff, you can access it. But now, how do we identify this staff user? How do I know that the people that is connected is a staff? And for that, we introduced a role table. So basically, it's a role-based access control, or RBAC. I think if you have a role in your software, you're doing RBAC, so who's doing RBAC? Yeah, pretty much everyone. That's the standard, right? So that's what we did. We introduced a roles table with the staff, and pretty simple, pretty straightforward. But then our project managers, they say, you know, we have misunderstood features or bugs, I don't know. And sometimes we need our staff to be able to help our customers, even if there is a subscription. But because when there is a subscription, you will have sensitive data, we want the client's approval. We want the customer, the client, to grant access to our staff, meaning they know what they are doing and they grant the access. And they came up with a great idea saying that only the administrator of the entity can grant access to staff. So yeah, we need to have the administrator notion, right? So to stay with the Batman example, Lucius, we know, is the one doing all the stuff in WenCorp, right? So he's the administrator, and only him can give access to the staff. So what we did is we introduce a Boolean, is admin, in the company user. Why a Boolean and not a role? Because administrator is a status. It's between a user and an entity. You can be administrator on an entity and not on another entity. So roles don't apply here. So it's okay to use a Boolean in this case. So we just introduce this one. But then we have a problem. Do you see it? How can I differentiate actual members from staff? Because staff can access, so they are members of entities, they have this relation, company users, entity users, but they have the role staff, but sometimes a staff can be a real member of the entity. For example, me, I have AGICAP for my personal playground, right? So I have a company in AGICAP production, and I also have the role staff. So I don't want, we don't want staff to be considered as members of entities, but sometimes they are really members of entities. So we can't only rely on the role. So what we did again, we introduced another Boolean, which is called is hidden. So to say that when you are a member of an entity and you have the role staff, but you are hidden, meaning you access this entity as a staff. Okay? So to summarize, if I want to know, can user Batman access entity WenCorp? What are the rules I need to check? I need to check is Batman is a member not hidden of the entity. So yeah, he's not hidden, he's a member, so he can go to the entity. It's a real user. But sometimes, maybe Batman has the role staff, and the entity has no subscription. So yeah, no subscription, he has the role staff, he can go. It's okay, it's demo mode, we don't have sensitive data. And sometimes, Batman has the role staff, and he's a needed member of WenCorp, so he has the role staff, he's a needed member, he can go. Okay, so I need to check this every time. Okay, so every time I need to access a resource of an entity, I need to check all these rules. So it's not very easy, and it became complicated, right? But now, I want to ask you again a tricky question. If I want only administrators or staff to see the payment, okay, I say it's okay, but to approve payments, I want only administrators, because obviously our staff can't approve payment instead of our customers, right? So I really don't want that. How can I use my actual model that I presented to verify this rule? Do you have an idea? Again, this one, right? Because if you are a staff but not hidden, you are really a member of the entity, so it's okay, you can approve payment. For example, our CEO, Sebastian, he can go to the AGICAP of AGICAP's own company and approve payment, even if he has the whole staff. But he can't go to another customer's company and approve payment, right? So basically, what I'm saying here is that to check a business rule, which is, can someone approve payment, my code will be, if easy done is true, he cannot. If easy done is false, yes, he can. You should start to see where I'm going with this, right? So this is the face of my project manager when I had to explain to him, yeah, on this entity you can approve payment, but on the other one you can't. And he said, why? Because of his hidden boolean, of course. I say, the what? The what? So yeah, this is real madness, right? And this is actually my face when the project manager started to say, hey, we want to change the rules. So maybe sometimes the staff, they can access entity, but for a specific amount of time, and maybe sometime when the moon, etc. And we were like, oh, this is becoming very, very complicated. We have booleans and everything. And yeah. The feeling we got here is that we need to master our data model, to master our business rule. I mean, it's okay to know your data model, and you should, but personally, it bothers me a little bit to explain to my project manager or other people or other developers coming to my team that, yeah, to enforce this rule can approve payment, you need to check this boolean. I mean, it makes no sense. Moreover, another interesting thing was when someone in my company asked me, "Yeah, can you tell me what an administrator can do in our software? I mean, what he can do? Yeah, all the rules, okay, and a staff also, and a simple member, what they can do." I don't know. I have to go through all the code base and to start looking for is hidden, is admin, is staff everywhere. And actually, I don't have a clear vision, a clear representation of my authorization logic. I know it in my head, but as you know, I didn't write a Notion documentation. So yeah, so I have to check all the code base to answer my stakeholders or product manager this question. So don't we have a problem of duplication and separation of concern and other problems? Yes, we have. So again, is access management a Boolean context? Or is it a specific part of every Boolean context? So if we look at our example, actually my authorization data, we have a little Boolean context here with roles. Maybe it's a little Boolean context for authorization. I have the subscription that is its own Boolean context and its own services. I also have the payment, and we have something called business definition when we have so the entity admin, the entity members, and this notion of hidden user. So if we look at this, our authorization logic is scattered all over the place, right? And we have also contaminated our business model with authorization notion, like this. Literally, I have contaminated this one with this Boolean. But, you know, authorization is so closely tied to the application that it can be challenging to design a clear interface between authorization and business logic. We can clearly see here that it's not a real separation. So business data and access management data, actually, they are coupled, right? And so the question here is where to put this logic, where this logic should be, when we can place it. So when we think of this, we think generally, as a good software engineers, with two different solutions, centralized and decentralized, right? So on the left, sorry. On the left, you have the decentralized version. So you have one service, and this service needs to have the authorization logic, but also the authorization data to make his authorization decision. And every service will have so it's decentralized. And the problem with this is that sometimes you will end up duplicating the authorization logic. For example, in our case, when we were checking the access to the entity with all the questions, you remember, all these questions, if I have a lot of services, I need to code this question and this logic in each of my services. So when this logic changes, I need to change it everywhere. And the same problem with the data. I need to access data to make this decision. For example, I need to access the subscription ID, the notion that there is a subscription or not. So I need to call my subscription service to know if the entity has a subscription. So I might end up duplicating the code to retrieve this logic. So not very good. And maybe we can have a more centralized approach where the authorization logic will be at only one place, right? And so the decision will be here, and these services can access all the authorization data he needs to make his decision. In this approach, the problem is that this service becomes a dependency for all other services, right? But at least you have the authorization logic at one place. But the other problem with this is that you need access to authorization data, and sometimes a lot of data. So it can be slow. It can be slow to retrieve all the data before making a decision. And because it's a dependency to every services, having a slow service is not ideal. And you will have a performance question to address. So why not? We had a service with both the authorization logic and the data to make the authorization decision. So everything. So who think it's a good idea to have a single model to rule them all? Not very DDD, right? As DDD practitioner, you should be triggered right now, no? So, yeah, instead of pulling data from various sources, we could assign the ownership of the data to a single services. So you must be triggered, but we must also think, okay, but what is this data? In fact, I don't need to absorb all the data from all my Boolean context. I just need the data to make authorization decision. And sometimes, like the rules, it's data only for that. Okay? So, yeah, I need only the minimal viable business data for access management. I don't need to all the data. So if we take the example of our members, so the fact that I have members, it's only data for my authorization logic. There is no metadata attached to it. It's just a relation, basically, with an entity and a user. So this can go to my authorization system, and it will be only here. And for the user, I just need the ID. For the entity, I just need the ID. So I don't need to absorb all the data. And actually, this is what Google did with the system Zanzibar. So Zanzibar is in production, and they have data ownership, and it was introduced in 2019, so 5 years ago, so it's pretty new. It's the Google centralized authorization management platform. It's highly scalable, and we'll see after. But what's innovative in Zanzibar is that it's based on ReBAC, so relationship-based access control. So in ReBAC, all of your data is relationship. Okay, so rather than focusing on roles, you focus on relationship. Okay, so instead of asking, does this user have role, staff, or whatever, you're asking, what relationship does the user have with the object of or resource, etc. So, and it's the kind of relationship the objects have between them that determines the business authorization rule. So, in other words, naming your relationship is using your ubiquitous language to describe your authorization rules, your business rule. And actually, Google popularized ReBAC 5 years ago, but it was invented much earlier, in 2007, to be exact. And like many cool things in computing, it was invented by a woman, so Carrie E. Gates. And okay, so this is the Zanzibar syntax. We will not necessarily delve into this one because it's complicated, but just the important thing here is to know is that everything is a string. Okay, so string is the best friend of your ubiquitous language. So if we take just this example, we have a user, so an object of type user with ID Bruce, who have a relationship member with an object of type entity with ID WineCorp. Okay, so that's pretty simple. And now we can modelize a clear interface. Okay, so it's pretty simple. We can have an authorization interface like this. You just need to give an actor, an action, and a resource. So basically, a user, an object or resource, and the relation you want to check. And it will say allow or deny. And that's it. So now our goal is to answer this question. Is user related to object with relation? So we always have who, so the user or the object, what, the relation, and to what, so the resource. So we can write this like this. Is user Lucius, so Lucius is the ID, related to entity WineCorp with relation administrator. So we will always ask a business question to our authorization system. And if the relation exists in our database, the system will answer true, and if the relation doesn't exist, it will answer no, and that's it. Just a few numbers for Google Zanzibar. So like I said, it's a centralized system, highly scalable. So it's used by all the Google service you know. So YouTube, Gmail, everything, it's Zanzibar behind them. And just to see the data, they have millions of access control lists, millions of authorization evaluated by seconds. They have a response time that is very low and high disponibility, of course. We won't delve into the scalability aspect because it doesn't apply to the average developer, right? It's described in the paper. It's very interesting, actually. However, the model part of the system, it applies whether you are a two-person startup or a large corporation. So that's what we are going to explore more. Another interesting thing about ReBAC and Zanzibar is this tweet from Lea Kissner. They are one of the designers of Zanzibar. And they said that an important thing when designing an access management system is reverse indexing or data filtering. What does it mean? It means that so you can check relationship, right? But you also can ask questions like, give me all the administrators of this entity, or give me all the entity this person is administrator on. Okay, so for example, reverse indexing will be like, okay, I want to know all the members of WineCorp. So, yeah. But the issue is that Zanzibar is a proprietary system. So it's not available to us. So they are in the private beach on the left, and we are with the mere mortals on the right. But obviously, there is open source solution. So there is a lot of solution. We chose this one. OpenFGA for fine-grained authorization. Why did we choose this one? For all the reasons mentioned here, and because we wanted to have something on-premise on our cluster, so we choose OpenFGA. And actually, the project manager is very, very nice, and they are a real community. You can ask them everything. We help them with a lot of tools, and they're very cool. So yeah. So now. if we get back to our example and we try to model it with the RBAC system, what we have, sorry. So in purple, we have our type, so entity, staff. I can make a type staff, users. And in green, we have our relation. Okay? So an entity has a direct relation member with user. And like you see, I said, for this example, member can view payments. So it's not a direct relation, but it's something I will be able to explain in my model. And yeah, that's our example. So I will show you. Yep. So this is the OpenFGA playground. So here on the left, you have the authorization model you can write. Here you have when I will save, it will update the graph. And here you can insert a tuple, so data. So if I take my previous example, we said that we had a type user, so I will have also a type staff, for example, staff, and a type entity. Okay. So there is my types. And now I want to describe my relation. So just relations, okay? And define. So the first one will be member. So I will tell member. So what is a relation member on an entity? It's between an entity and a user. Yep, can save. So this is the first relation, okay? So as you can see, it's pretty easy to read. And then I can insert tuples. So I will insert data. So for example, user Bruce is member of entity Wayne Corp. Up. Save. And then I can ask, is user Bruce related to entity Wayne Corp as member? And when I do that, I have this graph that says, yes, it's a direct user with the relation member. So now I can continue and introduce our other relation. So we had the administrator relation. So an administrator is a user. And what it's nice here is I can write this and a member. No, sorry, it's not it, excuse me. So an admin, you can have a relation admin on entity, and then I can say member are direct user or admin. So with this syntax, I can say all administrators you are inserting, you are designing on this entity are also members. Okay? Then we have the staff. I can say I can have the staff relation on entity. Again, it's not user this time, but staff. The type is staff. Up. And then we said that we can see payment. See payments. So who can see payments? Admin or staff. Okay. Up. And who can approve payment? Only staff, right? No, only admin. Payment, so admin. Okay. And last one, who can grant access to entity? So I can have a relation grant access. We said admin. Up. And you see, I have a clear representation of my authorization model, sorry. Now when my business manager or project manager, when they ask me, okay, can you tell me all the rules we have in our software, or the thing we can do, the staff can do or whatever, I say, yes, an admin, I can see that on entity, he can see payment and approve payment and grant access. And a staff, he can only see payment and is not considered a member. Only users directly that they have the direct link or admin are considered member of the entity. So now it became really simple to answer question. And if my product manager say, you know, in fact, we had a problem last year. Some of our staff, he saw the payment for La Folie Douce, and yeah, we don't want staff to see payment anymore. Okay, no problem. I just, that's it. Our staff can't see payment anymore. So this is the playground, but actually what we are using is more in code. So we have a model in our repository. Donc it's the same model, I think, that I just wrote. And a cool thing also is that you can split this model into several files. So, for example, our model became quite complex. So we split it for the different teams. So teams or bounded context. So each bounded context have its own file, so they can manage their own relation. And then you can use. They have a CLI, OpenFGA CLI. You can test. So you import your model. You have your tuples. So it's like your given. You insert your data. So here, Bruce is a member of entity Wayne, Lucius is the admin, and Gordon is the staff. And now I can write tests like this. Approve payment, only admins can approve payment. So user Bruce, I check that user Bruce on entity Wayne approve payment is false because he is a member, but Lucius can, and Gordon, which is a staff, cannot, right? And I can just test it like this with a simple command line, and that's okay. So if we say, for example, that we made a mistake, and for approved payment, we said our staff. Okay, if I go back to my test, now it's not passing, and it says, I expected to be false, but I got true. That's not it. So with this kind of test, you put, we put in our CI, we are sure that when someone modify the authorization model, we don't break anything in production, right? Okay. Yep. No. Sorry. Yes. So key takeaways. Authorization rules are business rules, right? And access management is a bounding context on its own. So I think we answered this question, I hope. And ReBAC is good like Ryan because you can use your ubiquitous language because everything is string. And a little anecdote. Do you know why they called their system at Google Zanzibar? Actually, there is a rumor that the project was about the spice, you know, because the spice in the series Dune, the books and the movie, it's a very valuable thing for them, and it's at the center of everything. So they had this idea about the spice and everything, and Zanzibar actually is called the Spice Island. So yeah, that's why. And so is it true or not? I don't know. I don't work for Google, but okay. So thank you, and time for question.
Thank you, Pauline. Oh. I don't get it doesn't work. Hello. I would with another mic.
Hey, that's better. Thank you very much. I was wondering if you had an idea or a way to include that also in combination with the role-based system, because we are not greenfield and sometimes you have to migrate or work in both paradigms together.
Actually, ReBAC include RBAC. You can have roles into ReBAC. you saw that the staff role, I put it into my model. So when you're doing ReBAC, you can do RBAC if you want. So you can have roles.
So that means that you will include as one of your entity type the role. Actually, it's one of your...
Yeah, you can have a type which is a role, or you can just put it on an object like I was doing. Like in the entity type, I put a relation which I call staff. Actually, it's a role on this entity.
Okay, thank you.
Yeah.
Thank you. Now it works. Any other question? Yeah.
Hi, thanks for the interesting talk. Can you tell us a bit about how the rollout went? Because you're centralizing something and now it's a dependency of everybody. Yes. And now all other teams will need to migrate their data in a centralized service and you will probably have a team owning it. So how did it go?
Yeah, interesting question. Actually, it's ongoing. We don't have it's not finished yet, but the most difficult part for me was to convince them to be more granular, because everybody was used to the simple question, can access entity, and just, okay, I can access entity, I can do everything. And we're like, no, you need to have precise authorization rules. So the first thing was to help them modeling their business rule, actually. So going with our product manager and their product manager and going to the OpenFGA playground. So we use a lot the playground to discuss our different model and to say, okay, so you need what are your needs in this part of the application? For example, payments. I need to approve payment, but I also have something like a cost center, and I need an administrator of the cost center, and this is the one who can give cards to. And we say, wow, you have a super use case. We can model it with a lot of different things. And then, of course, because we need data at some point, we need tuples, right, in our database. So we need them to insert this data. But actually, our platform, OpenFGA instance, is just the container. It's like we are responsible for it, but not responsible for the data inside it. You know, so it's their responsibility to make sure that they push the relevant data for the authorization rule to happen. So, for example, for the members, when you are creating an entity, when a customer is creating an entity, we need to have those relations, those tuples in our system. So we need to make sure when creating a new entity that, for example, the creator is a member of this entity. So you need to have consistency and maybe to put patterns to make sure that this data is correctly inserted. So yeah, that's a change. But you know, it's already what we were doing, because when creating an entity, you have to make sure that you insert in the database this relation. So now you have to make sure you insert it through an API call. So it's not that complicated.
Thank you.
You're welcome.
I guess we have enough time to another question. Yeah. Can you forward?
Wow.
Thanks for the talk. Can it also handle where you, if you have a structure like an entity and you have lower levels on it, sub-entities, okay. And if you're an administrator on the higher level, you're also administrator on sub-entities?
Yes, okay.
Is that something that it...
Yes, maybe I can show you. Okay, so I think you are thinking of like an organization. So, for example, we have an organization, yes, type organization, and I can say, for example, I can have a relation on my entity. We can do it both ways, but I have to choose one. So I can say organization here. Organization, yes. Up. Organization. So now I have a relationship, so I said this entity is part of this organization, and then on organization I can define also an administrator, define admin, which is a user, okay, and I can say now admin of my entity are directly admin. I can point them, or I can say admin from organization. Yep, that's what you were thinking.
Yeah, something like that. Yeah.
Okay.
Okay. Thanks.
Another question, perhaps?
Well.
Thank you.
In the example you gave, where an administrator can give access to a certain entity, how is that checked in this descriptive language if the administrator, if the staff member or whatever has the access to that specific entity?
Okay, so the first thing we will do is that this rule. So grant access, only an administrator can grant access to an entity. So in your interface, when you will check, hey, I am an administrator and I want to give this staff an access to my entity, you will check this relation. Does the person who is connected has this relation? And if yes, you will insert a tuple in your model, which is staff. So I will have user staff. Sorry, I will have staff Gordon, which is now which has a relation staff with entity Wayne. So this is the data will be inserted in your model in your system. Sorry, to make sure that you can do it. And now, when the staff is connected, we will check if this relation exists to say, hey, okay, you have access to Wayne core, or if the relationship doesn't exist, you don't have access.
Thank you.
Another question,
On the
perhaps? Yeah, on this. Oh, okay. Next one. This side. Great.
Close. Yeah, thanks for the talk. I was just wondering, slightly on a different note, what the sort of institutional backing for OpenFGA is, because I feel like that's getting more and more important, that you have some sort of confidence that this project is going to continue, especially if it implements its own strange DSL, because you want to be able to teach people that, knowing it's not going to become this strange dead skill if the project doesn't have the kind of backing it needs to survive. So is it CNCF or?
Yes, it's CNCF.
Okay.
Yeah,
That's
it's
good.
CNCF, and actually I think they are in the sandbox right now at CNCF. They have been accepted as a sandbox, and I check you can see the projects at the order of the project. So the first one is obviously Istio, and I think OpenFGA is 8th position. So just behind the open feature. So I think they have a good feature. Yeah.
Great.
Okay. Yeah. We have enough time for the last question. Wow. Oh! Sorry for that.
Okay, thank you very much for the talk. One question is, the code needs to be updated in order to check for these rules enabled. I mean, you probably need, when you have a feature in the code, you need to check is this request coming from this user fulfillable or not. How do you verify that the code has the correct references to the model and the rules that are referenced in the code are actually present in the model?
Yeah, that's very interesting. In fact, in OpenFGA, you have a model, and when I change it, it creates a new one. Okay, so with a new ID. So you have all your models. You don't delete it. Okay, so it's a new model. And in fact, I didn't show it here, but when you're asking OpenFGA for through the API for a check, you must give the store ID. So for my example, it's DDD op, okay? And you must give the model ID you want to perform your action. What we did is that we didn't want all our services of our team to be aware of the model ID they have to interrogate through API. So we coded a facade behind OpenFGA. So our service is called ReBAC, so ReBAC AGICAP, okay? So it's called ReBAC, and actually it's only ReBAC that has the model ID in its configuration. And so when it's fully automated, when we update the model, so we push the new model to a repository, it then updates the M chart of ReBAC to say this is the new model. ReBAC restart in production, and everyone is now checking the new model. So that's what we did. And also we are in C#, so we have a NuGet package, and at the same moment we update our model, we update this package with the new relation. So when people they are coding in the services, they use the package to have the correct name of the relation, because like I said, everything is string, so if you mess up, it doesn't work. So yeah, we use this kind of system. So we fully automated everything through our CI, and that's it. But like I said, I was discussing with the product manager of OpenFGA, and he said that yeah, it's a pain for all the users to have to give the model ID every time they ask the API, and he was thinking of doing something like us, like saying maybe we have a facade and which knows the model ID, and everyone who go to the API, they don't have to know the ID because it's painful. You know, you have to replicate the configuration to all of your service. So yeah.
Thank you.
Thank you, Pauline. Please, an applause for Pauline.